Okay, so how do we use our calculator? So now we're doing the outhouse problem, and I already put in F1 the function itself. So let me just clear here just to make it a little easier for us to follow what's going on. We have a couple of options. One option is to ask the calculator to take the second derivative or the first derivative and put it in y2 and then look at the graph of that. There's lots of different ways, and just to show you how to do that, if I want to take the derivative, a lot of times it's a little bit hard to find the actual math functions when you're in the graphing function. But we have a little cheat for that, because if you look over the number 8 in blue, it's that letter D. That means to take the derivative. So you can ask it to take the derivative of y1, start parenthesis, x, end parenthesis, comma, x. So you're basically telling it, find the derivative of the function y1 that I put in earlier, and then with respect to x, and then enter, and it'll put it in there. Right now, both of those functions are active. So going to the home screen, we're going to ask the calculator to solve this. And by the way, there's no trig in here. If it was trig, the grapher is your best option. But because there's no trig, I'm going to use the algebraic function of solving. And we're going to take the derivative and set equal to 0. So I put the derivative in y2. So I'm going to do y2 of x. So using function notation, oh, I forgot a parenthesis, of x. So y2, start parenthesis, x, end parenthesis, because that's, you got to use function notation, and set that equal to 0. So take it and set it equal to 0. And then we want to solve for x. So you said comma, x, end, and enter. And it'll give you the value like that. The other option, which is a little more complicated and convoluted here, is you could use the solver. So again, F2, and then ask it to take, if you didn't put in y2 the derivative, you could also ask it to take the derivative of y1 and set it equal to 0. So you have to say, take the derivative, which is over the 8, of y1, y1 of x. I don't know why it changed the view, but y1 of x. So we're going to find x of x there for x. I don't mean the number 4. It's like the word FOR. For x, so comma x, like that, end parentheses. So now in the solver, we're asking it to find the derivative, and then we have to say, okay, take that derivative and set equal to 0, so equals 0, and then we have to say comma, solve for x, so comma x. We got to ask it to solve for x, and then end parenthesis, and then enter. And it will give you exactly the same thing. It's just a little more convoluted this way in trying to enter it. That's why I suggest that in y2 you put the derivative, but it really is up to you. All right, so now what we needed to do was we needed to check the endpoints of those values. So again, there's a couple of things you could do. First of all, let's say I wanted to find the decimal notation. I could go up and look, I'm using the arrow key to highlight and then hit enter, and it puts it back in the active bar. So I can highlight whatever I'm looking for and then push the diamond and then enter, and that's the decimal representation. I could just store the value, so I could ask it to store it right away. So hit store at the end, and let's put that in the letter A. So the letter A would be here. Enter. So now it's done that, stored that in A. The problem it does with the solver is it says x is equal to an A, so it's not really helpful to do that. So what you're going to do is you're going to go grab the solution instead, enter. So look, I highlight, I can do that again, even if I did it as a decimal. If I go up and highlight and hit enter, it puts it in the active bar. So I'm going to hit clear again because I accidentally put 2 things. So go up and grab what I want and hit enter. And for me to store it, I'm going to put it in store in letter A. But the one thing you have to be careful of is that you have right now X is equal to in the front of that. So I'm just going to go and delete that. Delete that like that. There we go. So now it looks more normal. Like that, and then hit enter. So now it's stored that in A. So now we had to check all of the endpoints. So I'm checking the endpoints. So I'm going to do y1. I got to check it. Extreme value theorem, we have to check in the original function. So y1 of 0 was the one endpoint is equal to, that was the square root of 10 if I want it as a decimal, like that. y1 of I also needed to check the value at A that I've now stored it in A. So store in A like that and enter. Okay, I want it maybe as a decimal, diamond, enter. So that's how we got that value. And by the way, this one I'm only getting 5 decimal places because I've set the calculus set to that. And then the other endpoint, y1 of 6 and enter, and it gives me a 2. So there I have all of those values that I need to be able to answer the question using the calculator. Some other features that are interesting on the calculator, let's say you accidentally just put the actual function in and you wanted to copy that somewhere else. I don't have that here, but let's say I wanted to take this. If you hit F1 right now, there's a copy feature here, copy number 5. And then right now on the clipboard in the calculator, this is stored that. So then you can go anywhere. Like for example, if you needed to put it in the graph down here, I could do F1 again here and then paste, because now it's stored for that. Not that it's helpful right here, but I'm just showing you that you could paste that there if you needed to. So it just pastes the whole thing, and it can just grab anything, use the arrow keys to navigate the home screen. You can grab any of those pieces and copy and paste it and put it wherever you need to put it.